Hey peeps. Okay, lesson 2 in our unit price and currency exchange unit. So just to recap, in our first lesson, we talked about ratios and rates and what the difference is between those. And you will also remember that I kind of started the lesson with this whole concept of rice to water, right? And we had talked about a ratio of 1 cup rice to 2 cups water. And then we said, oh, okay, well, that could be a liter of rice to 2 liters of water, or a gallon of rice to 2 gallons of water. But here's the thing. What if I want 3 cups of rice? Or what if I want 7 cups of rice? Okay. How can I adjust my ratio so that I can figure out if I want to change one item, how does the other item change so that the ratio stays the same? Okay, that's what proportional reasoning is all about. A proportion is really just a fraction that equals a fraction. Okay, all right, so we can totally do this. Here we go. Proportion is a statement of equality. Equality just means that they equal each other, okay, between 2 ratios. If we think back to yesterday, we see that the ratio when cooking 1 cup of rice needs to be the same as the ratio when cooking 4 cups of rice. This is a proportion. So what we do is we say, okay, if the original was 1 to 2 and I want to change this to 4, well, there's a couple different ways I can think about this, but here's the first way I want you to consider. How do I go from 1 to 4? Okay, well, I multiply by 4. So whatever you do to the top, you have to do to the bottom. So I have to multiply the 2 by 4 as well. Okay. The other way to look at it is a process called cross multiplication. Now, I'm not a big fan of the word cross multiplication because I find that students often come to me and they use it in the wrong context. The only time that you can use cross multiplication is when you have a fraction equals a fraction. Okay. When it is 2 fractions, nothing else, but when it's 2 fractions that equal each other, then multiplying the diagonals will always equal each other. So look at this. 1 times 8 is 8. And 2 times 4 is also 8. So I'm going to try and show you kind of both of those as we go. Okay. All right. So find the unknown value in each of the following proportions. So we're going to go through both examples or both methods, I guess I should say. The first thing I might want to ask myself is, how do I go from 8 to 24? Now, just for clarification, when we say, how do I do this? We are always thinking about multiplication or division. We're never thinking about addition or subtraction. Okay, so how do I go from 8 to 24? I multiply by 3. Well, whatever I do to the bottom, I have to do the same thing to the top. So if I go 7, oh, sorry, I was thinking about the 7, so I wrote 7. That should be a 3. Okay, so if I go 7 times 3, I'm going to get 21. Okay, so that means x has to be my 21. Okay, the other way to do this is through this cross multiplication. So I can go 7 times 24 and 8 times x. Now 8 times x is 8x. Okay, and then 7 times 24, I do have this in the PowerPoint, but I'm going to grab my calculator and just do it with you. 7 times 24 is 168. 168. Okay, now I have a little algebra problem, right? I have 8x. I want to get to a statement that says x equals something, which means I have to get rid of the 8. Well, what is the 8 doing to the x? It's multiplying. So to get rid of it, I want to divide. And then when I go 168 divided by 8, I get 21. Okay, whoa, that was a really bad x, sorry. X equals 21. Okay, so both methods work. The cross multiplying will work even when you don't quite see how you go from one number to the other number. So there's a little bit of an advantage there. Okay. Let's try 19 over x equals 38 over 100. Now you can do both the same methods. You can say, okay, how do I go from the 19 to the 38. Some of you may see that and say, oh, I'm multiplying that by 2. So now you could answer, okay, well, what number would I need to multiply by 2 to get 100? Or if you wanted to go backwards, I could say, hey, if I multiply by 2 in this direction, I would be dividing by 2. So 100 divided by 2, it's going to have to be 50. Okay. Now, the other way you can do that is with the cross multiplication. So we would go 19 times 100. That's 1900. And then x times 38, that would be 38x. And we would get something like this. Okay. Then I divide both sides by 38 and get x equals 50. Okay. Awesome. See, we can do this. Okay, so that leads you to the on my own questions. I'd like you to give number 1 and 2 a try. Just pause me, try those. Remember to check your answers at the back of the lesson and then come back and unpause me. I'll be here waiting for you. Okay, so let's take a look at, welcome back, by the way. Let's take a look at class example number 2. I'm just going to hide my head for a sec because I might be in the way of the 35 pies there. Okay, so I'm just going to read the question. Stefan baked 12 pies in 5 hours. If Stefan baked 35 pies, approximately how many hours did it take him? Okay, so this is just like we did on class example number 1. The difference is you have to build a proportion, okay? So in class example number 1, I had given you the proportion and you just had to solve for the unknown. Okay, so our proportion is going to be pies to hours. Okay, so we know that Stefan baked 12 pies in 5 hours. So that's our first guy. 12 pies in 5 hours. Then we're being asked, okay, Stefan bakes 35 pies. So 35 will be on top, and I don't know how many hours, okay? Well, now I'm back to where I was in class example number 1. I've got a proportion, I've got a fraction equals a fraction, okay? So I can just cross multiply. The reason I'm gonna go right to cross multiplication on this one is because I probably off the top of my head don't know how to do 12 times 35. Now, or 12 times whatever equals 35. Sorry, I didn't say that right. But some of you may have been taught just to reverse engineer it and go, okay, 35 divided by 12, and that'll give you your magic number. If you like to do that, like if that's comfortable with you, that's an awesome strategy. Go ahead, use it, okay? So I'm gonna go 5 times 35 and 12 times x, and that's gonna give me 12x, that's the 12 times x. And 5 times 35 gives me 175. Now, algebraically, I have to get rid of the 12, so I'll divide both sides by 12. And that gives me 14.58. So I'm going to conclude that it takes Stefan just a little over 14.5 hours to bake 35 pies. Okay, a little over 14.5 hours. Okay, awesome. Class example number 3. The ratio of cocoa to flour in a brownie recipe is 1 to 3. If a baker is using 12 cups of dry ingredients, so that's the cocoa and the flour are considered dry ingredients. So he's using 12 cups in total. How many cups of cocoa and how many cups of flour does she use? Now, the trick to this is we need to be thinking about the total, but we weren't directly given the total. We know, okay, so let's just write this out for a sec. We have cocoa to flour to total is what I want, okay? So cocoa to flour to total. Now, I know that cocoa is 1, flour is 3. Well, then what would the total have to be? If I put a cup of cocoa in a bowl and I put 3 cups of flour in a bowl, how many total cups do I have? I have 4. I just add them together, okay? All right, so now I'm told, hey, I'm gonna have 12 cups in total. So I know that my new total is 12. So now I'm just gonna ask myself, how did I go from 4 to 12? Well, in order to do that, I multiply by 3. So I'm gonna do the same thing to the rest of them. 3 times 3 is 9, and 1 times 3 is 3. Okay, so in my 12-cup recipe, I'm gonna need 3 cups of cocoa and 9 cups of flour. That way, my cocoa and my flour are gonna be in the same ratio, okay? Now, just in case I stressed you out because some of you at home, if you didn't have the book, you didn't see the words, I'm just gonna hide my face so that you can take a screenshot with the whole question in it, okay? I didn't mean to hide my face that long. I couldn't find the button to bring my face back. Okay, there we go. So we end up with 3 to 9 to 12. Okay, so 3 cups cocoa, 9 cups flour to give me 12 cups in total. All right, you guys are awesome. Now we're gonna go right back to the Now You Try. You've got a few more to try here. That's questions 3 to 10. Try them, check the answers in the back of the lesson. And actually, you'll notice that that brings us to the end of our second lesson together. Okay, so now we have completed pages 7 to 10. Make sure you've gone through that. Give yourself some time to make sure you're comfortable with everything. And always, always, always check in with me if you have any questions. Okay, I'm here to help. You guys got this. I'll see you soon.